Jai Hind all of you. Myself Nishu Bansal from the CSC department AKGEC. We are doing the lecture video recording of another lecture that is on the subject database management system. Subject code is KCS 501. The topic that we will be doing today is enhanced entity relationship diagram. Let's see the various outlines of this particular topic. First, we will see the EER stands for the enhanced relationship diagram, that is it's advance of the entity relationship diagram that we have seen in the previous video of this particular subject. Then we will see at the various modeling concepts of the EER. Then we will see the additional concepts of which are included along with the ER, that is the subclasses, superclasses, specialization, generalization, categories, that is the union types which are included in this particular ER. Then what are the attribute and the relationship inheritance. Then finally we will see the aggregation. So let's see the subclass and the superclasses. Basically when we talk about the data within the database, it's not just we are just storing the data. We have the data which may be representing the real world entities. So we need to categorize further or subclass the entities into various groupings. So for that purpose, we have is the subclass and the superclass concept and how we can represent them in the real life conceptual scenario, that is using the enhanced ER. So here, for example, we have is the employee. So employee can be further subgrouped into depending upon the employee's job into the secretary, engineer, technician. So they may not be doing the same kind of work within an organization. So we need to categorize them depending upon the kind of work they are doing. Similarly, we may be having managers. So employees who are managers. Likewise, depending upon the method of payment. That is, we may be having certain employees which are salaried employees and certain employees which are hourly based employees. So this is how the subclasses or the superclasses can be designed. So ER diagram, it extends the ER diagram which we have seen in the previous video to represent these additional subgroupings. And these subgroupings are called the subclasses or the subtypes. So here's a diagram which shows how we can represent the various classes and their subclasses using the EER diagram. So similarly, as we are using the concept of rectangles are used to represent the entities. So here employee is our superclass entity. Here all the attributes of the employee are represented using the ovals. So they may be having various attributes like name, SSN, birth date, address, and further name may be having various because it's a composite attribute. So it can be further divided into these particular attributes. Now, we can categorize this particular employee based upon the type of job. These are the specializations of the employee. So, we can have secretary, technicians, engineers. So, they may be having their own specialized attributes such as typing speed. Likewise, technician may be having the grades, technician grade. Engineers may be depending upon the type of engineer. So, they may be having their own specialized attribute. That is the ENG_type. Likewise, employees can be the managers which may be managing the various projects within an organization. So, depending upon the salary structure, the employee can be a salaried employee or they can be paid on the hourly basis. So, they can be the hourly employee. Salaried employees, they have the attribute salary, and the hourly employee, they may have the pay scale and they may belong to the trade union also. So this is a way how we can represent the superclass and the subclass in the EER diagrams. Now, each of these subgroupings is basically a subset of the employee entity. We know if we talk about the subclasses, that is a secretary, a subclass, it actually a subset of the employee entity. So each is called a subclass of the employee. Likewise, employee is a superclass for each of these subclasses. So how we speak regarding that particular relationship, it's a superclass subclass relationship. So employee/secretary, employee/ technician, employee slash manager likewise. So these are called is-a relationship. So when we talk about the subclass and the superclass, the relationship is a relationship. So secretary is a employee. Here on the left hand side we write the subclass and on the right hand side we write the superclass. So this particular is-a shows that it's a superclass subclass relationship. So technician is a employee. Note an entity that is member of a subclass represents the same real world entity as some member of the superclass. So definitely the entity which is in the subclass would be a real world entity in the superclass also. So all the entities or all the members of the subclass would definitely be the, we can say implicitly it would be the members of the superclass also. So subclass member is the same entity in a distinct specific role, only that they are playing a particular role. So entity cannot exist in the database merely by being a member of a subclass. It has to be the member of the superclass also. A member of the superclass can be optionally included as a member of any number of its subclass. It's not necessary that all the members of the superclass would be in its subclass. They may be in the different subclasses also. So, example here we have a salaried employee who is also an engineer belongs to two subclasses. That is the engineer subclass and the salaried _ employee. They may also belong to two different subclasses also. So, salaried employee who is an engineering manager belongs to three subclasses. That is manager, engineer and the salaried employee. So it is not necessary that every entity in a superclass be a member of some subclass. So we may have some subclasses which don't have all the members in the superclass to be the members of its class. So here's we know that this particular thing represents the specialization. So depending upon the job type, employees being categorized into secretary, technician and the engineer. Now how the attributes are inherited in the superclass subclass relationship. An entity that is a member of the subclass inherits all the attributes of the entities as a member of the superclass. As we know, if we have a particular entity as a member of a subclass, it would definitely be inheriting all the attributes of the superclass also, because it would be the member of superclass. So all relationships of the entity as a member of the superclass. Not only the attributes, it would also be inheriting the relationships also. So here's in the example in the previous slide, secretary as well as technician and engineer. It inherits all the attributes, that is name, SSN, all the attributes from the employee. As we can see, the employee has these particular attributes. So these all attributes would be inherited by secretary, technician and engineer subclasses also. Along with it, they have their own specialized attributes also. So every secretary entity will have values for the inherited attributes. Now specialization, let's see the formal definition for the specialization. Specialization is the process of defining a set of subclasses of a superclass. That is, we are dividing a superclass into the subclasses. The set of subclasses is based upon some distinguished characteristics, as we have seen, of the entities in the superclass. As we have seen, ki secretary, engineer, technician is a specialization, we can say, of employee based upon the job type. So we have several specializations of the same superclass. It's not necessary that based upon only one category we are having the specialization. Depending upon various different attribute types or the relationship types, we can have the different subclasses. So let's see some other example of the specialization. that is specialization of employee based upon the method of payment. So salaried employee and the hourly employees we have. So superclass, subclass relationship and specialization can be diagrammatically also represented in the EER diagram. So attributes of the subclass are called specific or the local attributes. As we have seen, secretary has the attribute typing speed. So the subclass can also participate in specific relationship types. For example, a relationship belongs to, it can only belongs to, that is for say the people working in the factories, they are actually hourly based employees. So they may belong to a particular union trade. So they can have specific relationships also. Now, if we have the specialization, reverse of that is, we know that is the generalization. So generalization is the reverse of specialization process. That is, several classes, they may be having some common features and we generalize them into a superclass. Original class becomes its subclasses. Okay, the original at the lower level, the classes we have is the subclasses. We can merge them based upon their common features and we may be having a superclass. So example, car, truck, generalized into vehicle. Both car and truck become subclasses of the superclass vehicle. So we can view car, truck as a specialization of vehicle. So it's a reverse process. The classes at the lower level, they are like the subclasses or they are specialized classes, and the one at the upper level is the generalized class, or we can say it's a superclass. Alternatively, we can view vehicles as a generalization of the car and truck. So here's the generalization. Here we have the classes, that is at the A, in the A point, we have individual classes, car and the truck. We know one is a light vehicle and other is a heavy vehicle, and they have their own specific attributes, that is a vehicle ID, license plate, max speed, number of passengers and price. Now, some attributes may be common in truck also. We have the license plate, number of axles, price, tonnage and the vehicle ID. So, what we have seen is there are three attributes, that is a vehicle ID, license plate and the price. They have the almost, these attributes are common. So, what we have done is car and truck, we have combined them and we have made a superclass vehicle which has got the three attributes, vehicle ID, price, license underscore plate, number as to be the generalized attributes, and their specific attributes are attached to their subclasses. So this is how the generalization is being done. So we have seen that it's basically the bottom to up process. That is, we have different subclasses, we merge them based upon their common attributes and we have given a journal class, that is the superclass. So, diagrammatical notations are sometimes used to distinguish between the generalization and the specialization. So, arrow pointing to the generalized superclass, it represents a generalization. That is, if we have an upward arrow, then that would represent generalization. So, arrows which pointing to the specialized class, that is, if we have a downward arrows, then we say that it is a specialization. But nowadays, we are not concerned about generalization, specialization. So, we don't use these kind of notations because it is often subjective as to which process is more appropriate for a particular situation. That is, it sometimes we don't need to differentiate now generalization and specialization. We know that it's a reverse process. So, we avoid not drawing any arrows. So, we can have certain constraints also on the specialization and generalization. Let's see what are the constraints. If all the subclasses in a specialization have membership condition on same attribute of the superclass, specialization is called attribute defined specialization. That means if all the members in the subclasses, they have, depending upon that is, they are contributing to a particular attribute, based upon that there is a condition which is applied to a particular attribute and based upon that they have been classified. So that is called attribute defined specialization. So attribute is called the defining attribute of the specialization. Like we have seen that we have categorized the employee into the secretary, technician and engineer based upon one of the attribute, that is a job type. So here the defining attribute is the job type. So this kind of specialization is, we call it as the attribute defined specialization. So we may have that no condition determines the membership. The subclass is called user defined. That is, I need to define certain subclasses, but there is not a single attribute which is defining the differentiating the subclass. So I can have that also. So membership in a subclass is determined by the database users by applying an operation to add an entity to the subclass. So membership in the subclass is specified individually for each entity in the superclass by the user. So here is the attribute defined specialization. As we have seen, depending upon the job type, we may be having secretary, technician and engineers. So it's a attribute defined subclass. Now the constraints, the basic constant depending upon this we have is the disjoint constant and the completeness constraint. Let's see what is the disjoint constraint. So disjoint constraint is, it specifies that the subclasses of the specialization must be disjoint. Okay, that means there should not be any member that is being shared by the subclasses. So entity can be a member of at most one of the subclasses of the specialization. We can't have a shared entity among the subclasses. So it's basically the main notation that we are using is D to show the disjoint constraint in the EER diagram. If not disjoint, then specialization is overlapping. That means we may be having an entity that can be shared by one or more than one subclasses. So that is the same entity may be a member of more than one subclass of the specialization. So we specify the overlapping using this particular symbol O in the EER diagram. Before we go into the EER diagram to show that, let's see what's the completeness constant also. Then we will show in the through an example both the constants. The total specifies that every entity in the superclass must be a member of some subclass in the specialization. Completeness constant says that in the superclass, all the members, they must be coming into some of the subclass members also. So that is shown using the double line. Now partial, in comparison to the completeness, reverse of that we have is the partial, which allows an entity not to belong to any of the subclass. So we may have members of the superclass which may or may not belong to the subclass also. So that kind of constant is a partial constant. So we show it through a single line. So when we combine all the four, we have four types of specialization: generalization, that is disjoint total, disjoint partial, then overlapping total, overlapping partial. So note, generalization usually it is total because the superclass is derived from the subclasses. Generalization in itself is total because it has all the members now. So here's an example of disjoint partial. We show the disjoint using this particular symbol. Within a circle we write the D symbol. So disjoint is, a secretary cannot be a technician. Similarly, if a member of secretary and technician is or technician is there, it cannot be a member of engineers. That means we don't have any common members in secretary, technician and engineers if we are using disjoint constraint. So here partial, it is shown using the single line, this line. That is, employees may be secretary, they can be technician, they can be engineers, but there may be certain employees that they may not belong to all these three categories. like manager. It cannot be a secretary, technician or engineer. Example of overlapping and specialization. Overlapping total specialization. Here part is a superclass. It's divided into or having a subclass manufactured parts and the purchased parts. So manufactured parts and the purchased part, there may be certain parts which can be manufactured as well as they are purchased. They may have overlapping members, and they may be all the parts would belong to one or the other subclass. Now, we have one more concept, that is the hierarchies and the lattice and the shared subclasses. So, a subclass may itself have further subclasses specified on it, and it forms a hierarchy or a lattice. So, hierarchy is basically we have a constant that every subclass has only one superclass when we say. So, this is called single inheritance, or we basically get a tree structure in this case. And lattice is we may have a subclass which can be a subclass of more than one superclass. So, this is called multiple inheritance, or we can say it's a shared subclass. So, here's an example of the shared subclass. It's very important. That is, we have an engineering manager. That is, a person may be belonging to engineer class also and can be the manager also. So, and plus it would be a salaried employee also. So, here an engineering manager, this is a shared subclass as it's formed of various other superclasses. So, in a lattice or hierarchy, a subclass inherits attributes not only of its direct superclass, but also all of its predecessor superclasses also. So, a subclass with more than one superclass is called a shared subclass. That is a multiple inheritance. And this is very important concept. What is multiple inheritance? So, we can have specialization hierarchies or lattice, generalization hierarchies or lattice, depending upon how they are derived. So, we just use specialization to stand for the end result of either specialization or generalization. So, now we are clear with that specialization starts with an entity type and we further refine it into the entity types by successive specialization. So, it's a top to down approach, refinement process, whereas generalization we start with many entity types and we have at the top we have the based upon the common properties one single superclass. So, it's a bottom up conceptual synthesis process. So, in practice a combination of both processes is usually used or employed. So, here's an example of a lattice or a particular specialization, generalization lattice example of the university. We have is at the top person, then we further it has got certain attributes. Further we have overlapping subclasses at this level, employee, alumnus, a student. So, a person can be the employee as well as the student also. For say a person is doing a PhD from the same university, they can be the employee also, they can be the student also. Then further employee can be the staff members, the faculty members, the student assistants, the employee plus the students. Then students can be specific graduates, the undergraduates, depending upon the degree programs. Then further the student assistants can be the research assistants or they can be the teaching assistants. So, this is the specialization generalization example for the university. Now, we have one more category, that is the union type. So, all of the superclasses, subclasses, relationships we have seen thus far have a single superclass we have seen. Na? So, a shared subclass is a subclass in which more than one distinct superclass, subclass relationship can be there. Each relationship has a single superclass. Shared subclass leads to multiple inheritance. This is what we have seen. But there may be certain cases, for say we need to model a single superclass, subclass relationship with more than one superclass. Okay. We have seen that subclasses, they were belonging to a single superclass. Just now we have seen. But now we may be having a case that a subclass may be inherited from more than one superclass. Now how we represent that? For that we have categories or the union type. Let's see an example. For say, in a database for the vehicle registration, a vehicle owner can be a person, a bank. In case we have taken the loan, okay, for the vehicle, then bank would be the owner till we give all the money to the bank. Or a company may be the owner if they are giving on the EMI. Then a category of the union type called the owner is created to represent a subset of the union of the three superclasses. That is a company, bank and the person. So a category member must exist in at least one of its superclasses. Difference from the shared subclass, which is a subset of the intersection of its superclasses. Shared subclass members must exist in all of its superclasses. Na? So here two categories, union type owner, registered vehicle. So here a owner can be the person, bank or company. It can be the union of any one of these or a union of this. So they own a registered vehicle. So this is an example of union type. Now the next last concept we are doing in this particular video lecture is the aggregation. So it's a process in which a single entity alone is not able to make sense in a relationship. So the relationship of two entities acts as one entity. First we take the relationship of two entities and make it a single entity. Then we further make the relationship with other entities. So likewise it may sound difficult, but let's see through an example here. For say, there is a manager which manages both the employees and the projects. Now, if we take different relationship of the manager with the employee and the project, it doesn't make sense because it's managing both. So here manager manages employee who works on the project. This is taken as a single entity. This is called aggregation. Thank you so much.